Scientists have made a bold declaration. They have located a celestial body distinct from any other previously known. NASA, renowned for its groundbreaking new information, has revealed that this planet is captivating not only because of its dimensions and location, but also because of the light it emits, light that seems artificial. Could we be on the verge of being exposed to facts that have the potential to improve our comprehension of the universe? Could this result indicate the possibility of life existing on other planets? By examining NASA's pioneering discoveries, we may soon uncover the facts surrounding this remarkable event. Dawn was launched by NASA in 2007 with the objective of investigating one of the most intriguing objects in our solar system. It featured a propulsion system with 3 ion engines. Dawn began its journey with a 14-month investigation of Vesta, the second largest asteroid in the belt. Dawn transmitted back extremely detailed images and data, illuminating Vesta's intricate surface features and diverse geological history. After completing its work at Vesta, Dawn moved on to the next phase of its voyage, probably even more exhilarating: an in-depth look at the dwarf planet Ceres. Thanks to its ion propulsion systems, Dawn was able to escape Vesta's gravitational pull and head toward Ceres, an achievement that would have been impossible using conventional chemical propulsion methods. These ion systems provided a constant supply of thrust, enabling Dawn to traverse vast distances and establish a stable orbit around Ceres, discovered in 1801 by Italian astronomer Giuseppe Piazzi. Ceres is the largest object in the asteroid belt, situated between Mars and Jupiter. It was classified as the smallest dwarf planet in our solar system for 4 years until it was recategorized in 2006, with an approximate diameter of 950 kilometers. Ceres stands as the largest object in the asteroid belt and one of the most enticing because of its unique qualities. Scientists eagerly anticipated the first close-up images of this mysterious planet, which revealed numerous brilliant spots across its surface, particularly in a massive crater. These spots sparked immediate interest and speculation in the scientific community. Before the Dawn mission, the best images of Ceres were blurry, low-resolution photographs taken by the Hubble Space Telescope. Very little was known about this dwarf planet, but the promise of in-depth observations excited astronomers and space enthusiasts alike. The Dawn mission aimed to improve our understanding of planetary formation and examine the role of water in the development of planetary bodies. The bright spots on Ceres, also observed on other asteroids, might be composed of highly reflective materials, possibly residual salts from evaporated water. This finding suggested the potential for cryovolcanism, a type of volcanic eruption that releases water or brine rather than molten rock. But what exactly are these enigmatic lights, and what do they reveal about the true nature of Ceres? Could they be signs of ongoing geological processes, or something even more extraordinary? Ceres distinguishes itself from other bodies in the asteroid belt due to its mass, size, composition, and the potential presence of water and ice. Unlike the typically rocky asteroids, Ceres has a more comet-like composition, suggesting it could unveil more secrets about the early solar system. After 2 years in space, the Dawn spacecraft began its approach to Ceres in early 2015. This marked a significant turning point as it prepared to provide the first comprehensive views of the largest body in the asteroid belt. As Dawn approached, the images became progressively sharper, revealing a world previously hidden from view. The initial pictures showed a cratered surface, suggesting a long history of impacts. However, what drew the most attention were the mysterious bright spots in the planet's dark, rugged terrain. As the image resolution improved, scientists began to formulate theories about the nature of these locations. Were they areas of ice, reflecting sunlight, or perhaps something else? Extraordinary speculation ranged from reflective minerals to possible signs of cryogenic activity. To everyone's astonishment, closer examination revealed that it wasn't just a single bright feature, but a collection of distinct areas. The most widely accepted explanation was that these were salt deposits left behind after water sublimated. This suggested that Ceres had or possibly still has some form of geological activity, with the potential to push water or brine to the surface where it rapidly evaporates, leaving behind bright reflective traces. These results challenged previous perspectives on Ceres, painting a picture of a dynamic and more complex world than anyone had imagined. The possibility that subsurface water or brine pockets could exist has profound implications for our understanding of the potential for life. Elsewhere in the solar system, Ceres is frequently referred to as an icy planet with a rocky but porous surface, in contrast to most asteroids, which are composed largely of rock and metal. Its surface is a mixture of hydrated minerals and water ice, including clays and carbonates, giving it a less dense structure than its rocky neighbors. According to this composition, Ceres may contain substantial amounts of water beneath its surface. Its outer rocky layer is porous and contains trapped ice and various volatiles, making it more like a comet than a typical asteroid. It is believed that Ceres has a unique internal structure, consisting of a rocky mantle and a core rich in water, ice, which makes up about half the planet's total volume. The mantle is probably a mixture of brine and rock surrounding a denser core, possibly made of silicates. The significant amounts of water ice raise the possibility that Ceres might once have supported liquid water, particularly when radioactive decay warmed the core during its early years. This internal composition distinguishes Ceres from neighboring asteroids and opens up intriguing questions about its potential for geological activity and the role of water in shaping its development. But that's not all. The identification of ammonia-bearing clays on Ceres suggests that this dwarf planet might have originated in the colder outermost regions of the solar system before migrating inward. The presence of ammonia could lower the freezing point of water, allowing for the presence of corrosive liquids on or near the surface. These insights into Ceres' structure and history not only expand our knowledge of this fascinating world, but also provide important clues about the processes that drive the formation and transformation of icy celestial bodies throughout the solar system. Cryovolcanism, as a system, is a fascinating and relatively uncommon geological phenomenon, especially when contrasted with the more familiar volcanic activity on Earth. Rather than spewing molten lava, cryovolcanoes erupt with icy substances like ammonia, water, or methane. These compounds can remain in liquid or gaseous form in extremely frigid environments in the Ceres. Allow salty water to rise to the surface thanks to subsurface activity. When this tough mixture encounters the empty space around it, it quickly changes, sublimating directly into gas from a solid or liquid state. What remains are salt residues that reflect light, mysterious in appearance and responsible for the bright spots observed worldwide. The brightest of these is located specifically in the R crater region, known as Spot 5. This site has drawn a lot of attention because of its extreme reflectivity, as well as the variations in brightness over time. These shifts are thought to be connected to water sublimation, subtly implying that cryovolcanism might still be occurring, or has occurred in the recent past. In addition to Spot 5, Ceres includes numerous other luminous spots, each exhibiting unique traits. These are not restricted to any one area but are dispersed across the planet's surface, indicating that the phenomenon may be prevalent. Their existence emphasizes Ceres' vitality and debunks previous notions that, as dawn broke, it was a still dormant body. As the mission carried on, transmitting increasingly detailed images, it revealed a surface dotted with craters, each narrating a section of the story about the planet. Insights from scientists have sparked new theories about this intriguing world. These revelations have fundamentally altered our perception of Ceres, with its icy appearance and evidence of potential chemical reactions. The planet is now seen as a dynamic and evolving entity, no longer just a frozen relic. The brilliant Spots, especially those in the R crater, continue to pique the interest of scientists. They may represent not only geological activity but also processes that suggest Ceres' ability to sustain subsurface water. A series of studies carries far more weight than simply understanding a single dwarf planet. By examining its interior layout, exterior anomalies, and bright deposits, scientists can derive insights into the behavior and development of additional icy bodies within our solar system. The materials on Ceres, such as water, ice, monomers, clays, and reflective salts, can shed light on the chemical processes and environmental dynamics of other planetary objects. This opens the door to cryovolcanism and enthralling new paths in understanding geological activity not only on dwarf planets and icy moons in our solar system, but also on faraway exoplanet. This indicates that regions once believed to be inert and uninhabitable may actually host complex natural processes. Could this also suggest that distant planets previously dismissed as frozen and barren might maintain the conditions required for life? Final thoughts on the Dawn mission by NASA. NASA's Dawn initiative continues to be a shining example of the possibilities of space exploration. The information it provided has already changed science's perspective on the development and evolution of our solar neighborhood. As we proceed deeper into Ceres' enigmatic mystery and those of distant celestial entities, each piece of evidence helps us assemble the larger story about how planets, moons, and other formations in the universe are currently changing. The bright areas on Ceres stand among the most fascinating puzzles in planetary science. But they represent only the beginning, as advancements in technology and newer missions are utilized. The potential for even more breakthrough discoveries rises. Ceres, once an unnoticed part of the asteroid belt, is now a symbol of intrigue and promise. Its layered terrain, complex interior, and opaque shining areas may one day unlock keys to understanding our solar system's youth and the mechanisms that forged its planets. The potential for life in the form of microorganisms, or at least the ingredients necessary for life to exist on Ceres, remains an exhilarating notion that keeps researchers and space enthusiasts alike motivated as our journey of discovering new frontiers continues. The lines separating reality and imagination grow ever thinner. What was once confined to science fiction, the possibility of alien life has evolved into a legitimate scientific question. Could microscopic organisms thrive in Ceres' hidden reservoirs? Might conditions similar to those on other icy celestial bodies prove hospitable to life forms, whether familiar or entirely unimagined? These are the mysteries that will serve as a model for the next space age to investigate and, perhaps, reveal deeper universe-wide truths.